Different levels, a lot of lectures, a lot of knowledge. This first part, this workshop is divided in actually two, I would say, mini workshops. On the first part, I'm going to be speaking about this over here that you see, love changes perception, which seems very interesting, and hopefully it is for you. On the second part, this is basically trying to understand how love gets into each one of our cells. We are sets of 70 trillion cells. So if we're going to study love in the body, and that's what we want to do today because it's love, like I said, in all different levels. So we want to see what happens at each cell. So this is a very scientific, technical approach to the subject. And right after that, Jusara is going to come in and gives us a more hands-on approach, more how to do it kind of things. All right, so we are going to start with this. Oh my God, everything's going fast. Hold on. We're going to start with this, with the idea that studying the body traditionally starts with biology. Many years ago, biology, studies the cells and everything, the tissues and all. And so there was a certain point where that wasn't enough because that does not address anything like emotions or behavior. So we felt the need to go a step higher. And that's when psychology and all its variations and everything related gets in. So we can study the mind. So now we're kind of leaving the body in a way. But there's more. That wasn't enough. There was a point where studying the body, studying just the mind separately, not connected, it wasn't enough. There was something else above all. And that something else was the spirit. Or the soul, as we say sometimes. Now, when we come from the bottom up, when you start with biology, you won't get to the spirit because of the limitations of the way this is done, this study is done. So we never get to love, we never get to emotions, whatever good or bad emotions, we never get up there because biology is just biology. It runs at the physical level, physical plane. Now, when you study Spiritism or spiritualism, and we are part of it, it's the other way around. You start from emotions and love and fraternity and everything else, and you come down. So your perspective, your angle of your approach is totally different, and things make a lot more sense. And that's what we're going to do today. We're going to take love, which is all the way high in the spirit level, and come down to the biological level, to the body, physical body. Allan Kardec in the codification explains to us, of course, through the words of the spirits, that there is a mediator between the spirit and the body. It is called perispirit. I represent it here just to make it easier visually, that we would be then three bodies. Spirit is not a body, it's just a reference to a more visual approach. So we would be this spirit, perispirit, and physical body. Again, we are concentrating on my first part here, on the physical body. How does love go? What happens at the physical level? So if we look at the physical body, there's different ways that biology and the material plan looks at that. One of them is this one here. We are mostly water, and that's interesting because if you know the Mr. Yamamoto in Japan, we know that he's been conducting research in how love applied to water changes the crystallization of the molecule. So that's a known fact today. It's no news to anyone anymore. But if you look at the second thing, or the second greater proportion, it's proteins. Proteins are what part of our cells. Our cells are made of proteins. So we want to take a look into that because it's 15%, so it looks interesting. Another way to look into the body from the biological point of view is the body, they call an organism, so let's just use the vocabulary from biology. The organism is composed of several systems. Digestive system, nervous systems, and so and so and so. Systems are composed of organs. So in the digestive system, we have a liver, stomach, and intestine, and different things. Organs are made of tissues. Tissues were made by cells. Cells are made by proteins. Proteins are made by amino acids. That's enough because it's almost endless. Right now, we are studying intermittent space between electrons in the DNA. That's how far it goes. So we can stop here for what we need today. But then, if I want to understand love, if I want to see what love does to me as a physical body, as an incarnate man, we need to go to the basic level. So we are going to concentrate on studying cells, proteins, and amino acids. And then you're going to see, what's love got to do with that? You don't have to think. The answer is going to come. So let's study the cells first. Let's see what's been discovered so far. Cells are traditionally divided for study purposes in 3 parts. We call the nucleus, the cytoplasm, and the membrane. We're going to have to see what each one does because each one of them matters when love is in place. And when I say love, it applies for bad energy too. If you understand the logic, you're going to understand what love does and what everything else does. All right, so I'm going to start with the cytoplasm. Cytoplasm is this, if you look at this middle part, the blue part, where you have a lot of different things in there, that's the cytoplasm. Traditionally, a cell has a nucleus where we call the DNA is, and everything else is the cytoplasm. There's a lot of things in the cytoplasm. There's organelles that each one does a different thing. Each cell basically is a living being. The same way we have to breathe, we have to inhale and exchange food and things like that, the cell does the very same thing. It does the same thing. So all these organelles, they have a purpose in the cell. For example, I have a purpose of having a lung, of having a stomach, and so on. So all these organelles will do something within the cell. Now, there's one of these organelles it's a special attention for us because of the works of Spirit Andre Luiz that explains very interesting things about this guy here. It's called mitochondrion. He explains that this is the core of metabolism. This is what creates energy. In each cell, we are sets of 70 trillion cells. So this mitochondrion takes oxygen and glucose and converts into physical organic energy. So I have muscles that I can do that I can walk, that I can just do my regular life. Now, what he explains is before this gets converted into energy, the cell, each mitochondrion in each cell asks the mind, what are you thinking today? What is your state? If you're in a state of love, fraternity, and charity, and so, the energy generated is compatible with that thought. If you're in revenge, if you're raging, if you're mad, the energy generated is compatible with that thought. So be careful because it goes down to the physical level inside each one of our cells. These mitochondria are inside our cells. There are several mitochondria per cell. Some of them have more mitochondria than others. Lung and liver cells have a lot more than others because they do a lot more metabolism. Anyway, that's the cytoplasm. So keep that in mind, we're going to come back here. Nucleus. Nucleus is traditionally where we think all the brain of the cell is. That's an old tradition from science. We know it's not that way anymore. That's been dismissed, basically. But inside the nucleus, that's where we have our genetic code. Through these little proteic chains called chromosomes. Chromosomes, when you look at it, it's something like that, like a double helix. We have 46 of these guys. One interesting thing is, if you take one chromosome, one of them, and this is a twisted pair of a double helix. If you untwist and you just do flat like on a table, this is going to be 6 feet, okay? If we do this for all the cells that we have in our bodies, if each one of them we lay flat, and then the next one, then the next one, then the next one, we're going to get 50 times the distance between the Earth and the Moon. So but this thing is all tangled, it's all wounded. It has to be unwound. Anyway, when we look into this, let's just take this twisted pair apart. Let's see what's in it. So it will look like a tape. If you want twist, it would look like a flat tape. And in this tape is what we call the DNA. And the way it works is, if you imagine looking at a physical tape, if I had one here, it is divided in small sections, not necessarily the same size. So there's a small section here, the next one is like this, then the next one is this, and the next one is that. Each one represents a characteristic of our body. These are called genes. So genes are what are going to be passed along to the next generation. It's going to be used for that, and not only that, to copy and make cells. Every time one cell dies, another one starts, is created, and it's created with the same basic genetic code. Now, one interesting thing about genes is they don't do anything. Genes don't do anything. Genes are in the nucleus of the cell, and they are there to tell the cell, somebody in the cell, we're going to see how, somebody in the cell, how to make a protein again. So I have to create a new cell. How do I do that? Well, if you tell me, can you make a chocolate cake? I'm going to say, yeah, but where's the recipe? Give me the recipe and I'll do it. That's what these genes are. They are nothing else than a blueprint, the instruction manual. They are the recipe book. Recipe books, think about this. You have a recipe book, and right in there, page 50, chocolate cake. The fact that I have a recipe book doesn't make the chocolate cake. It requires an intelligent principle that reads the book, goes through the ingredients, and so puts in the oven, and so and so and so, and then I have the chocolate cake. So the recipe book itself doesn't do anything. The genes don't do anything. They are references. They are reference tables. They are lookup tables. So for a very long time, we thought that genes were the brain of the cell. They would do a lot of things. They don't do anything. They are reference tables. And I just mentioned to you, as you see here, that they are made of proteins. And then we go like, well, what is this? What are these proteins? Well, you see some interesting information here. The body produces between 100,000 and 150,000 proteins. And again, how are these proteins created? By the recipe book. So each time a protein is created, I have to look up the book. I have to go to the lookup table and see how it's made. So there's got to be somebody, there's a reference in the body somewhere telling me how to produce these cells and these proteins. And these proteins are made of something that we call amino acids. And that's where things start to be more clear to us, Spiritists. In order to try to explain to you without being very technical or very scientific, I'm going to use a few tools here that I have. Let me get them for you. So what we do is this. Proteins, as you see here, are chains of amino acids. So I'm going to use these things as if they were amino acids. This is one amino acid, if you want to imagine that way. Here's another one, and so and so and so. The way it works is these amino acids connect to each other, just like that. So I have two amino acids connected, and then another one comes in, and then another one comes in, and it goes like that. Okay? Now, what's interesting is each and every amino acid is electrically charged. Okay, so if this guy here is positive, the next one has to be negative, because that's how they approach each other. And the next one has to be positive, and the next one has to be negative, and so and so and so. So let's just say, for us to be able to think a little bit about this, that here is a protein made of these 4 amino acids. And let's just imagine this. This is positive, and this is positive. Okay? Then another amino acid plugs in. If this guy is positive, this is negative. Okay? That's how they bind together. Now, when this happens, now I have a negative here and a positive here. What's going to happen to those extremes? They try to attract, right? So the protein goes like this, because this is a more stable structure than this, considering that this is positive and this is negative. So the protein does like this. And then another amino acid comes in, and it's going to open up. If this guy goes away, this thing will open up. When he gets in, it closes like that. So this is a continuous, unstoppable movement of amino acids. And this is, from the biological point of view, for biology, this is life. So life is this extremely intense movement of proteins and parts and so like that. Well, what's love got to do with that? What are we getting there? Because when we look at the next part of the cell, which is the membrane, things start to get a little more interesting. Let's say, for example, just for us to think a little bit, that this room here, with all of us is a cell. And each one of us is a protein. So I am protein Luiz Lima. Each one of you is a different protein. And let's say, for example, that the cell has to survive. It has to have control mechanisms to be able to survive. So let's say, for example, that we can't see what's outside because this is a closed room. I can't see outside. So there's a membrane here, which are the four walls. Now, let's say, for example, if it starts raining too hard out there, if we don't do anything, we're going to get flooded. So there's got to be a mechanism of control. Somebody here inside this room has to be able to take action when there's a signal that it's pouring out there. If you don't do anything, we're going to get flooded. This is done through the membrane. And how it's done like this. Not all the proteins are inside the cell. If you look at this drawing here, this is the drawing of a cell membrane, and you see some of these guys like this. They have halfway in the cell, halfway out the cell. Now think about this. If you're in the cell, you can't see what's outside. But if this happens, okay, when another amino acid plugs in here, what happens down here? This is going to change. The fact that this change tells everybody in the cell, this is happening. I don't have to see. There's an indication here. This is happening. So, for example, if we had, let's just say, a red light here on the ceiling. When it pours out there, the red light goes on. So we know it's pouring. Let's take action. The action is protein Luiz Lima has to, let's say, just close all the windows. Let's just put it this way to make it easier. So it's a very simple process if you think about it. But the problem is, proteins like these, they form and they go away. Amino acids plug in and they unplug, they're going to do something else. So there are times in the cell where the protein is not there. So what happens if the light goes on here, okay, so the receptor on the external part is there, so the signal is received, the red light goes on, and Luiz Lima is not in. Are we going to die? It can't be. There's got to be a mechanism of control. There's got to be something that controls. The way this happens is there's a supervisor, and the supervisor is the guy looking for responses in the cell. So the red light goes out. After a certain time, the supervisor says, Luiz Lima is not responding. Maybe we don't have him in the room. We need to produce. We need to create a Luiz Lima so he can take action. How is that created? I need a recipe book. I need to produce that protein. I need to go to the book. The book is the gene. So I go to the genes, I create protein Luiz Lima, and Luiz Lima takes action. And then he goes, closes all the windows, and we keep going like this. This is a very dynamic, intense process, you can imagine. Very quick. It doesn't take all this time. It's unbelievable fast. Okay, that's interesting. So you see this thing here, the fact that the cell has receptors outside its membrane, or antennas if you want, in a more popular language. These are basically antennas. These are the ones that are going to tell the cell how to act. What happens inside the cell depends on what happens outside. That's interesting because then, just by that, it's unpredictable what's going to happen to a cell. You can't foresee because it depends on what happens on the outside. So there's no genetic determinism. We can't have it because the cell response depends on the stimulus, as we call it. The stimulus is this guy here coming outside the cell and producing this movement here. So this is the stimulus. All right, in terms of just a block diagram of everything that I said, the stimulus comes in, it plugs into one of these receptors. The stimulus could be some of these things here, glucose, insulin, hormones, one of these things, and many others. These are just simple examples. So when, for example, when the cell receives adrenaline, okay, this is my adrenaline here. It plugs in and something happens here. And the cell knows, oh, there's adrenaline out there. Let's do something. So somebody in the cell has to take action. Otherwise, the cell will die, okay? So the stimulus comes in through these receptors. They are received. The protein moves inside. And then here's the question. Is the matching protein, the one that we need to take action, is it live in the cell? Just like I said, is Luiz Lima in the cell? If he is, he's going to do what it has to do and it's all done. But if he is not, we're going to have to produce Luiz Lima. So we go, we alert the supervisor, which is called regulatory protein, okay, for all purposes, just to use the name. Then we're going to access the DNA, we're going to access the recipe book and see how do I produce protein Luiz Lima. Then I go through the recipe, but the thing is, when you go to the recipe book, you can't take the page. You have to copy it. Otherwise, if you take the page, you can never produce that again. It wouldn't make sense. So that stays, you can copy. So that recipe book is copied over, and the protein is built, and then something happens. In our case, I'll go just close the window so we don't get flooded. This is the process. And again, it's a very, apparently very simple process, but we're making it very simple. It's not really that simple. So by now, we figure out that genes don't do anything. They are recipe books. They're pretty much static. They don't do anything. Somebody on top of them tells them what they're going to do. Somebody has to tell the cell, hey, this is happening. This is the stimulus. So there's got to be control above the genes. And we started having this very clearly in 1960, 1967, when we were doing cloning, because we would take the nucleus out of the cell wouldn't die. So it wouldn't make sense to think as of that day that the cell has its brain in the nucleus. So we started studying that, and later on we discovered that it wasn't that way, and a new science was born. That science is called epigenetics. Epi means above, so it's above the genes control. It's a science that challenges classic genetics very much because it understands the nature of these stimulus and what's going to happen inside the cell. So things are changing. But how did we go so wrong when we found out in 1953 the structure of the DNA, the double helix? How come we did so wrong? How come we didn't notice all of this? We came to know this many, many decades after. Well, think about this. In 1953, when they were trying to find the structure of the DNA inside the cell has 1 million proteins moving all over the place. It's like trying to find a needle in a haystack. So what do? You start setting things apart. This is not the needle. This is not the needle. This is not the... Oh, I found the needle. That's what you do. Okay, the problem is when we, quote, threw out what was not the needle, we didn't pay attention to what they were. So we found only 50% of the answer. The other 50% was what we threw out. There were other proteins in the nucleus, in the cell, and those are the ones that control the DNA. Those are the ones controlling all the genes, and we threw them out in 1953 and the years following. Now we know it's not that way. That's why we had a hard time until recently to understand cell behavior and protein behavior. So classic genetics looks only into these three things. DNA, which is my recipe book, produces protein. Now, epigenetics, which is above, considers stimulus and what happens in the cell when this guy here plugs in, okay? So it's a beautiful study. It's a long study, very long. But some of the interesting facts about when we started studying and going deeper into this, 95% of the cancers don't have anything to do with mother and father that we believed they were. We always believed until then that they were. They're not. 95% of the cases have nothing to do with that. There's no relation. Another thing is the placebo effect, where you can tell somebody, you can give him a pill that's not really a pill, it's just sugar, and tell him, this is going to cure your whatever, cancer, and it does. It wasn't the sugar. It was the mindset. It was above the genes. You were able to tell the genes, turn off this cancer because I'm sick and tired. I don't want this anymore. So what happens is this stimulus here could be something that I see as positive or negative. Think about, for example, drugs, okay? People who do not do drugs. For these people who do not do drugs, this is bad. For people who do drugs, this is nice and beautiful. It's the same stimulus, but it's a different response here. Now, if this was only mechanical, okay, when I plug this moves exactly the same no matter what. But it's not. It's the same stimulus, but for one person, this is going to do, let's say, this, and for another person, this is going to do, let's say, this, which sets a different response within the cell. So for some people, some of these signs could be positive or negative. If you have something that is positive, as you see here, it's going to put the cell in growth mode. If you see something as negative, it's going to put the cell in survival mode, and it's either or. If you're surviving, you can't grow. If you're growing, you don't need to survive, you're just growing. It's either or. It's basically a choice. It's a perception. From here, we go into, just think about this. If we are the cell here in this room, and somebody walks in with a gun shooting, okay, shooting up like that, we would probably run to the furthest point that we can, because this is just natural instinct. So, and if somebody comes over here to the door and say, hey, people, there's free chocolate cake, everybody goes over. So I will approach or run from it, depending on what that means for me. You see, it's the perception. Now, this is only at the cell level. Now we take this cell level study, multiply by 70 trillion, because we are 70 trillion cells, and we go to a body level. What happens at the body level when you look at a more robust thing? Certain things will attract me, certain things are not. It's still my perception. When I get attracted by something or I perceive something as good, my immune system goes up. When I see something that's not good, doesn't attract me at all, my immune system goes down. Of all the things that can set my immune system all the way high, and I can perceive as the most intense positive sign, it is love. And the one that makes me perceive that is the worst toxin, the worst possible thing, is fear. These are the two extremes. So you see, biologically, it's not love and rage or something like that. It's not. At the cell level, this is what it is. A cell in fear won't grow. A cell that grows is not in fear. And so is the whole body, 70 trillion cells. So in the past, we thought that it was something easy like that. There's a stimulus and a response. Not anymore. We know it's not that way anymore. There's a filter, and the filter is the perception. It depends on how I perceive this thing here, what it means to me. And it doesn't mean the same thing to everybody. And perception is backed up by the environment. What is the environment? Each cell is in an environment, like a fish tank. Imagine 70 trillion cells in a fish tank. That's what the environment, the external environment is. And this guy here, the stimulus, comes from the external environment to plug into the receptors. This is floating out there in the external environment. And then André Luiz comes to explain to us what is this. Look what it says. Domesticated infinitesimal animalcules abide to simple or complex thoughts that define their existence. Yeah, it's complicated. Let's go simple. Let's go one by one. Domesticated. What is domesticated? Something that obeys. Like a dog, domesticated, obeys the owner. Okay? Infinitesimal, very tiny. Animalcules that go by instinct. So when you put these three things together, he's telling us that our cells are these. They obey the owner. The owner is the spirit. It's very clear on the Spiritist literature. So love will create a nice environment within each cell and a general feeling of wellness. Anything else, any negative energy is going to create the other way around. Another thing that André Luiz tells us is, medicine will come up with 1,000 ways to help an unhealthy body regain its internal balance. That's at the physical level. However, it's up to us to practice the medicine of the soul. That's to fix things that are up there. No revenge anymore, but love. No dishonesty anymore, but honesty. No intolerance anymore, but tolerance. That's what's going to fix. That's what's going to take us into a different dimension. All organs, again, André Luiz, are subject to moral ascendancy. Moral ascendancy. We're talking about organs, physical organs, and there's moral ascendancy. He's not talking about biological ascendancy. You see how things are all integrated because they are in the same environment. The environment is the mindset, is what I think, it's how I perceive things. So, how do we get to a conclusion here? We know now that genes and proteins don't do anything. They follow rules. These rules depend on what we call epigenetic factors, which are the perception of the environment. That sets the pace for what my genes and my proteins are going to do. Now, the environment comes from the mind, right? It comes from the perispirit, which in turn comes from the spirit. So if you look at this graph here, the first 2 parts on the left, it's us. This is us. And the 4 parts on the right, it's them. It's biology. They study that. We study the 2 on the left. They study the 4 on the right. It's well divided, but they are different studies. They are different angles of seeing the same thing. Now, if we look at this from the moral aspect, the same graph from the moral aspect, what we have is a more evolved soul will generate more elevated thoughts, which will generate a more refined perispirit, which generates a better quality of vital fluid, which is what transmits the information over to the physical body. It's a more robust connection. It's less interference. And then we're going to have a healthier body. So in short, we take all of this and we can just see simple things when they come up, like this. Love takes into healing. And healing depends on love. Healing is the physical healing or illness in this case, is the physical result of the lack of love in every single cell that we have. 70 trillion of them. Shushara is going to take you now into a different journey, a more hands-on approach. Thank you very much. Enjoy our day here.